Hello everyone, thanks for checking out this video today on solving quadratics by completing the square. We're going to do just a few problems together here, and then I will have you try 8 on your own using whatever method you find is best. All right, well, let's first talk about completing the square and then using square roots afterwards. So when we complete the square, usually we'll do this after we look at a quadratic and we realize we cannot factor it as is. What you want to do when you decide to complete the square is you want to make sure that the a is 1. Now in our example here, a is 1, so we don't have to do that first step here. Then what you're going to do is you're going to take the constant and move it to the other side. So in our example here, we're simply going to add 1 to both sides. Then we're going to add b over 2 squared to both sides. What does that mean? We're going to take the number here, divide it by 2, and square it. Whatever that is, in this case it's going to be 2 squared, which is 4. We're going to add it to both sides of the equation. Okay? And I obviously forgot to write it on the one side. My fault. Equals. There we go. So we added 4 to both sides of the equation. We added to the left and we added to the right. Then we're going to factor. Now, the left side sometimes now will be really easy to factor, sometimes it won't, but I can tell you it's always going to be factored the same way because it's completely square. It's always going to factor to x plus or minus this number squared. So x plus 2 squared. Whatever this number is right here will always be the number that will be here. And here it says 5. All right, then we solve this by using square root method that we talked about previously. So take the square root of both sides. We get x plus 2 equals plus or minus root 5, which is not a whole number, so we'll leave it as root 5. It doesn't reduce to anything either. And finally, subtract 2, and we get our answer is negative 2 plus or minus root 5. And that's it. That's as far as we can go. Now, if you'd like to try one on your own right now, you're welcome to stop this video and try this one. If not, I'll walk through this one as well. So we see that we have x squared plus 6x minus 8 equals 0. If we try to factor this, it might look like it's factorable, but in reality, it's not. There's no way we can get a 4 to 2 to multiply to negative 8 and then add to 6. So we have a couple options where we use quadratic formula, which we'll talk about at another point, or we can try to complete the square. You see this is already 1, so that's good. Now let's just add our 8 to the other side. b over 2 squared, so 6 over 2 squared is 3 squared, which is 9. So I'm going to add 9 to both sides. Factoring on the left, remember it's always going to be x, and then this number, so in this case it's plus 3 squared, equals 17. And now solving this via square roots, we get x plus 3 equals plus or minus root 17, which does not reduce. And then finally, negative 3 plus or minus root 17. All right, another example here. This time we notice that a is not 1, so we're going to divide everything by 2 first. So we get x squared plus 4x minus 7 halves equals 0. Then we're going to add that c term over to the other side. And now b over 2 squared is 2 squared, which is 4. So we're going to add 4 to both sides. Factoring on the left, it's always going to be x plus this number squared, so x plus 2 squared. 7 halves plus 4 is 7 halves plus 8 halves, which is 15 halves. Take the square root of both sides. We have x plus 2 equals root 15 halves, plus or minus. We can't reduce root 15. We can't reduce root 2, so it's just root 15 halves. And subtracting 2 over, we get negative 2 plus or minus root 15 halves. Okay? Now, that's acceptable answer, but some people might want you to rationalize the denominator. What does that mean? So if we rewrote that like this, technically we're supposed to multiply this by root 2 over root 2. So our answer would be negative 2 plus or minus root 30 over 2. So this is called the rationalized answer. All right, so at this point, I have 8 problems spread over 4 slides that I'd like you to stop and try on your own. You can use whatever method we've learned in the last 3 videos. You can just try factoring each one, you can try using square roots on each one, or you can use completing the square, or use substitution as well. But after each one, you can always come back, pause the video, and check your work, check your solutions, and I'll talk briefly about each one as we go. At this point, I would suggest you pause the video and at least try number 1. Come back when finished. All right, so here's number 1. This is a pretty straightforward square roots method. You get plus or minus 5. Again, after each one, pause the video and try the next one. Here's number 2. This method would be best by completing the square. Number 3 is a fairly easy factoring problem. Number 4 is another completing the square problem, where A was not 1. That was a tricky one. A lot of work with fractions there. Number 5 was a factoring problem. Number 6 was definitely a square roots problem. Number 7 is a use substitution and a factoring problem. And finally, number 8 was a factoring problem. All right. Thank you very much for checking out this video today. Hopefully by now you have a firm grip on factoring quadratics, using square roots on quadratics, or finally now, using completing the square on quadratics. Thanks again, and we'll see you next time when we talk about the quadratic formula.